Hey y'all, welcome back. So today we're going to be taking a look at Lab 4, which is looking at potentially where Wisteria, which is an invasive species, could live based on data that we currently have around its precipitation, temperature, and the current sightings that are crowdsourced from the GBIF database, which compiles things from eBirds, iNaturalist. It's a crowdsourced version of things, and so that's what we're going to do. So what we've got right here is we have our two data sets. We've got our Wisteria with geodata. This is the sightings of Wisteria. We have our county temperature and precipitation. So this is going to have the average temperature and precipitation for July for both for all of the different counties, and then we have county boundary files. And so we're just going to be working with these three data sets in this case. So what I'm going to do is I'm going to add it in. I can either do that using this add data and going and finding it, or in my case I'm just going to drag and drop these ones in. So with this, what you'll notice is that our county boundary files show up the way that we think they should. So we've got these nice county files right here. But you'll notice that these CSVs, or these tables, don't actually show up with anything. They are just down in this standalone table. So I can't actually see them. There's nothing there. And so the very first thing that we need to do is get these into some sort of GIS format. So one of the best ways to do that is to right-click on them, open up the table, and see whether or not there's anything in here that can be used as some sort of spatial marker. So in this case, we've got the different country codes here, so that could potentially be something. But in this case, we have decimal latitude and decimal longitude. So what this means is we can actually use these two files, or these two columns in our attribute table, to create a spatial file with them, or a shape file with them. So that's what we're going to do with the Wisteria data. So we're going to right-click on the Wisteria data, and then depending on what version of ARC you're using, this may say display XY points and display it as either a layer or a feature class. You're going to want to do it as a feature class. In some of the newer versions, it says create points from table. This is what we're going to do now, and we're going to do XY to point. So we're going to click on that one. Now it's going to open up this dialog box right here. So our input table, we don't want to change what that value is. That is what we're putting into this. So we're going to keep that. Now, what you may want to do is switch out what you want your output feature class name to be. This is going to be important in this case because we're going to be using this data set later on. So you're going to want to actually have this data. And so what I'm going to say here is I'm going to call this GBIF underscore Wisteria. There we go. And then I don't, because I'm leaving it in a geodatabase, I don't need a field after it. If you're moving this into a folder, not the default geodatabase, you're going to want to add a .shp at the end. This just gives it a file type that it'll understand if it's not in a geodatabase. We can leave this coordinate system as WGS 1984 and hit OK on that. Once we do that, you'll notice that you get this yellow one. Yellow isn't terrible, it just lets you know that something went wrong. So in this case, 1, 2, 3, 4, 5 of these points didn't have data attached to it that would create a point on the map. In this case, we don't really care about that. In crowdsourced data sets, oftentimes there are those types of things where the data is not consistent across all different forms of people who've created them, or different places where they've aggregated it. So it's okay. And in this case, you can also see that we've got points all over the globe, including in the US, which is where we're going to actually be doing some work. So that's the first one. So now we can open up this other one, and we can say, all right, let's open up this table and see if there's an XY data. And so we'll notice here that we've got precipitation, we've got temperature, we've got AFGEO ID, state number, count number, state, county, and ID. And so there is no decimal latitude and longitude. And so this is a different form. So we're going to need something that is going to be able to be attached to a different data set that already has the spatial information attached to it. So there's nothing in here that's going to relate directly to the Wisteria ones. But what there is you'll notice this AFGEO ID column. This AFGEO ID column is something that is very common in US Census data sets. It is a very common way to reference counties. And so if I go over into this county boundary file that I gave you, and we go over here, we'll notice some of the similar things. We've got states, counties, this NS value, and then we also have this AFGEO ID. So this AFGEO ID is the full version of that. We want to make sure that they match in terms of their actual values coming out of it. And so we have this 0550 US 01001. Here we have the 05, the US, the 21007. So this is the right format of things. And so when you are trying to attach things together, you have to make sure that the information in each of the columns is going to match. It doesn't necessarily matter that the name of the column matches, but it is incredibly important that the data in there matches. So what we're going to do in this case is we are going to right click on the data set we want out. So in this case we want the shape file out. So we're going to right click on the county boundary files. We are going to go over to what is called joins and relates, and we're going to add a join. So this join says, hey, I'm going to look for information in one point of my data, and in my other point of my data, try and put them together and match them like a key to a lock, and then that's going to lock in all of the information from my table into some sort of spatial data set. So in this case, I've got this county boundary files. So it automatically, in my case, selected AFGEO ID. If it doesn't, you're going to want to click on AFGEO ID. And so you want that as your input table. Your join table is the thing you want, the information you want to join to it, and that is also going to be your AFGEO ID. So you're going to take a look, make sure that it's the thing that you want, you're going to click AFGEO ID. And I actually already have the join in here, so I'm going to quickly remove that join so that you see what it'll look like. Actually, maybe I don't. Weird. That's okay. Okay, so we're going to add that join. We've got this county temperature. Oh, that's right. That's fine. It was in the county temperature and precipitation. That's what we want. AFGEO ID. And then we're going to click this validate join. So validate join tells you how many things actually match. So you'll see that there's a variety of things. It's checking to make sure everything's fine. It's checking that there's a one-to-one join. And then at the bottom here, it says a one-to-one join has matched 3,106 records. The input table has 3,233 records, and the join table has 3,107 records. So what this means is that from the table, there's only one record that didn't match for whatever reason. That's actually pretty good. Oftentimes, if you have the wrong columns, it'll say something like 0 have matched, 1 has matched, 5 have matched. If you have a really low number compared to what you're expecting, then you're going to want to double check that you have the right input fields in both of those. So, but 3,106, that's fine. So we're going to close that. We're going to say, yep, that's great. And then what you'll notice, so I've got this county boundary files, and you'll notice that now I have all of this extra information that was originally in my county and precipitation data set. Now, what I'm going to do here, so joins are fine, but sometimes it doesn't love to have those things kept. Sometimes it breaks. Sometimes it does weird things and it breaks. So to make this hard-coded in, so to make this one data set that is not just connected by this thread, what I'm going to do is I can right-click on the county boundary files, go down to data, and click export features. This is going to allow me to create a new data set. In this case, I'm going to say county precipitation, temp, and precip. So I'm going to say I want to export this. It's going to have the county precipitation and temperature. I'm going to export my features. There's a new one that pops up here. If I right click on this one, I can open up the attribute table, and all of those same files are in here. Now, this is a good thing to have, just because if something happens, and let's say I had removed this one and I removed this one, or I tried to do certain things with my county boundary files one, sometimes it ends up with this kind of weird situation where it doesn't work or it throws errors. You don't want that, so I typically just hard code them in unless I'm working in a geodatabase where I don't need to. So with that, I can actually remove all of those files so that it's not confusing, and then I can go over here, remove this county boundary files. I now have my county temperature and precipitation and my GBIF, and then we can start to work to figure out where these different wisteria are going to be located, and we'll be back to that in the next video.